Hi everyone. Today we're going to be talking about division. So the example that we have for division is 27,692 divided by 23. And first let's just start off by reminding ourselves what division is. Division is when we distribute some amount of stuff equally among a bunch of groups and then count how much ends in one group. So today we're going to be working on long division, which is a type of division that we use when we have bigger numbers. So here's how we're going to set it up. We're going to take the first number and we'll rewrite it. And then we're going to put a bar on top and a bar on the side. And then we'll put our second number on the outside. And as we go through the problem, it'll make sense why we have it set up this way. But for future reference, our quotient, or the answer to this division problem, is going to end up on the top of the answer. So a little bit different setup than our usual problems, but it'll make sense as we go through. So next I'm going to show you this problem in block form. So what we want to do is take the number that we are dividing into 23 groups. So we have 27,692 of something, and we want to divide that equally among 23 groups. So first we're going to write out this number in block form. So we have 2 super rods, 7 super cubes, 6 flats, 9 rods, and 2 singles. So first what we're going to do is we are going to look at just the 2 super rods. So we're going to put these aside for a minute. So if we start with just 2 super rods, that's going to be starting with just this first 2 in the first number in our problem, the number that we're dividing. So we want to divide these 2 super rods into 23 groups. So if we draw our 23 groups down here, and we won't draw all of them just for the sake of time. So we'll just do a dot, 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 and we'll do our first group, second group, all the groups in between, and then our 23rd group. And we can do this because all of our groups are going to have the same amount of stuff at the end. So we can really just look at one group. So if we were to divide these 2 super rods into 23 groups, would we be able to split these up equally? Not really, because we can't split one of these here. We would only be able to split it into 2 groups because we only have 2 of these units. So that's the same thing as asking ourselves, how many times does 23 go into 2? Well, 23 can't really go into 2. So we would put a 0 here, but since it would just be a placeholder and we know that all of the numbers that come before our final answer would be 0, we don't really need to put it, so we'll just move to the next number over. So then we ask ourselves, how many times does 23 go into 27? Well, that 23 goes into 27 one time. That's the same as breaking these super rods down into 20 super cubes. So if we broke down this super rod into 10 super cubes and this super rod into 10 cubes, we would have 20 cubes left over, plus the 7 cubes that we start with from the 27. So then we can, since we broke down these super rods, we can take those away and just look at the super cubes. So now we want to see how many of these super cubes we can divide into each group. Well, since we saw how many times does 23 go into 27, it goes in one time. Each group is going to get 1 super cube. So we'll draw that down here. And going back to why we didn't put a 0 above the 2, because 23 goes into 2 0 times, that's because we wouldn't need to draw out a super rod here because we don't have enough to put into all of the groups. So we just didn't draw a super rod, just the same way as we just didn't put a 0 above the 2. So now what comes next in the algorithm for division is we do 1 times 23, and then we're going to write it below the 27. So we did 1 times 23, we wrote it below, and that's because we want to see, once we divide up all of these supercubes into our groups, how many we have left over. So we do 27 minus 23, and that's going to give us 4 supercubes left over. So say we divided all of these, that was 10, we divided all of these 10, and then we divided three more into all of the groups. We were left with 4. So we can put these aside now because we've already distributed them. And we have 4 supercubes left, just as we did 1 times 23, and we did 27 minus 23 equals 4, just as we had the 4 left over here. And now what we do is we bring down the number that's next over. We're going to bring it down to put it next to this 4. So now we have 46. And the next thing we ask ourselves is, how many times does 23 go into 46? Well, 23 goes into 46 2 times. So we write a 2 above the 6. This is the same thing as looking at our flats. So originally we started with 6 flats, or this many flats. But since we couldn't divide these last 4 supercubes into our groups, we want to divide up these supercubes, or break them down into 4 groups of 10 flats. So now we have 46 flats, just like we have here. So we took each of these supercubes and we broke them down into groups of 10 flats. So now we have a total of 46 flats that we need to divide up among our groups. So we said, how many times can we put 23 into 46? And it was 2 times, so we put a 2 above. And then we do 2 times 23 to see how many we are distributing, how many we're distributing total out of these flats. So 2 times 23 is 46. So you write the 46 below, and then we're going to subtract to see how many of these flats, after we've distributed them, we have left over. And since it's 46 minus 46, we have 0 flats left over. So we show that by writing 2 flats in each of our groups. And if we wrote that out for all 23 of the groups, we would have divided up all 46, so we would have none left over. So again, we divided the 46 flats. We divided all of them up into all 23 groups, and we didn't have any left over, so they can all be set aside. And these were broken down earlier into our 4 groups of 10 flats. So all of these can be set aside because we've already distributed them. Now by bringing down this 9, that leads us to look at how many rods we have. And we have 9 rods. Now because 23 can't fit into 9, if we were to divide all of these up equally, we wouldn't be able to get at least 1 in each group. So we're going to put a 0 above the 9. And then we do 23 times 0 is just 0. Subtract 9 from 0. And we're still going to have 9 rods because we haven't distributed any of these yet. So now what's going to happen is we're going to have to break down these rods into 10 singles each. So we do that here. So we broke down each of these rods into 10 singles, and that gave us a total of 90 singles here. And because we have that 2 from the original, we bring down this 2. And now we have a total of 92 singles. So we can cross these out because we distributed them, or we broke them down into 90 singles. So we can set that aside. And now we can just look at our 92 singles. So how many times does 23 go into 92? Well, we might have to do a side problem for this one. So let's do 23 times, maybe let's say 4. 3 times 4 is 12. Carry the 1. 4 times 2 is 8. Plus 1 is 9. So that gives us 92. So we know that 23 goes into 92 a total of 4 times. So then we do 23 times 4 just as we did here. And that gave us 92. And we can subtract. And we know that we have none left over. So 27,692 divided into 23 groups gives us 1,204 in each group. So if we were to divide up these 92 singles into 23 groups, we would put 4 singles in each group. And then all of these were distributed equally, so we have 0 left over. So we can set those aside. And then you have your final answer of 1,204. So if we go back to the definition, just remind ourselves of what we did. We distributed some amount of stuff, so 27,692, equally among a bunch of groups, so 23 different groups. And then we count how much we have in one group. So if we look here, we have 1 supercube, 2 flats, 0 rods, and 4 singles. And that gave us our final answer of 1,204.